All right, today we're going to dive into a really powerful idea in modern software called event streaming. It's all about a shift in thinking, treating your data less like a static, quiet lake and more like a constantly flowing river. And to show you why this matters so much, we're going to start with a single, pretty shocking number. $2.3 million. Just let that number sink in for a second. In the world of tech and software, what could a number that huge possibly represent? That's what it was. $2.3 million in transaction data that just vanished. Proof, gone. Like it evaporated into thin air. So this is the big question, right? How on earth does a company lose that much data basically overnight? And here's the wild part. This wasn't hackers. It wasn't some server catching fire. Nope, this entire catastrophe was caused by a very common, very standard piece of technology that was built on a fundamentally flawed assumption. Okay, so let's get right into it. To really understand the solution here, you first have to understand the disaster. And trust me, this was a big one.
So here's how this nightmare unfolded. Picture it. It's 2 a.m., middle of the night. A routine payment system is just chugging along, processing thousands of payments. Now, the key detail here is that the system is designed to delete each message right after it's processed. Then, at 2:47 a.m., boom, the database where the orders are supposed to be saved crashes. The payments all went through, the money was taken, but the record of what people actually bought, it's gone. And because those messages were deleted, they are gone forever. So by 9 a.m., the company wakes up to absolute chaos. Finance is staring at millions in charges with no orders, and customer service is just getting completely hammered.
And the total cost? It's just staggering. On top of the initial $2.3 million in disputed charges, the company had to spend another $180,000 in overtime and 6 agonizing weeks just trying to piece everything back together manually. But you know what the biggest cost was? The one you can't put on a spreadsheet? Customer trust. It was completely lost. So what was the real culprit here? What was the single point of failure that brought this whole system to its knees? Well, it all comes down to one core concept. The root of this entire problem was something called ephemeral messages. The system was basically treating every payment message like a self-destructing note. Once it was read by the next step in the process, it was deleted forever. So when that next system, the database, crashed, there was just no way to get that note back. It was gone. You can't reread it, you can't audit it, you can't recover from it. And this right here is the fundamental difference. With the old message queue system, messages are fragile. A consumer reads it, and poof, it's gone. If that consumer crashes right after reading, that data is lost to the universe. But with event streaming, the events are durable. A consumer reads an event, sure, but the event sticks around in the stream for 7 days or even longer. If a system crashes, it's not a panic. You just fix it, go back to the stream, and replay the events you missed. It's a total game changer for reliability.
Okay, to really make this whole idea stick, we're going to use a simple but really powerful analogy that software architects use all the time. The river versus the lake.
So first, let's talk about the lake. This is your traditional database. The data is at rest. It's just sitting there, still and calm, waiting. If you need something, you have to actively go to the lake with a bucket, that's your query, and bring the data back with you. The data doesn't come to you, you have to go get it.
Now contrast that with the river. This is data in motion. It's an event stream. You don't go to the river, you just stand beside it, you subscribe, and the data flows to you in real time as things happen. And what's really cool is that multiple different systems can all drink from that same river at the exact same time without interfering with each other at all.
This table really breaks it all down. The lake is a pull system, you go get the data. The river is a push system, the data is sent to you. The lake works in batches with delays of minutes or hours. The river is real time, we're talking milliseconds. And recovery is a huge one. With a lake, you're restoring from a backup. With a river, you just replay events from any point in time. It's an entirely different, much more active way of handling data.
Okay, analogies are great, but let's make this super concrete. Let's see how this actually works in a real-world e-commerce setup. So with the old lake approach, an order gets saved to the database and just sits there. Then your email service has to constantly ask the database, hey, anything new? Anything new yet every 10 minutes? The inventory service does the same thing every 5 minutes. This is called polling, and it's slow, inefficient, and puts a ton of unnecessary load on your database. Now look at the river approach. An order-created event is published one time. Instantly, the email service, inventory, and analytics all get the message at the exact same time. It's fast, efficient, and so much cleaner.
And the benefits here are just fantastic. First, everything is real-time, updated in milliseconds. You completely eliminate that wasteful polling, so your services only do work when there's actually work to do. This means your analytics dashboards are always fresh. And maybe the best part is that your services are decoupled. The order service doesn't need to know or care who's listening downstream. It just sends the event. You could add a totally new service next year, have it replay all of history, and it will be completely caught up. That's incredibly powerful.
So does all this mean you should just throw away your databases and make everything a river? No, not at all. This isn't about one being good and the other being bad. It's always about using the right tool for the right job. You absolutely still need a lake. You use it when you need to store that single authoritative source of truth, like a user's account balance, or when you need to run really complex analytical queries for a big report. Lakes are fantastic for looking up a specific record on demand or for storing data that doesn't change very often, like user profiles.
But you need a river when real-time is what matters most. Things like live dashboards or notifications. You use it when you have a bunch of different independent services that all need to react to the exact same trigger. And, as we saw in our big disaster story, you use a river when you absolutely must have a replayable, bulletproof audit trail of everything that has ever happened. The most powerful systems, though, they actually use both together. It's not a competition, it's a partnership. An event flows down the river, triggering all those immediate, real-time actions, like sending an email or updating inventory. But at the same time, another service is also listening, and its only job is to take that event and write it into the lake for long-term storage. This way, you get the absolute best of both worlds. You get the incredible speed of the river and the deep analytical power of the lake. So the big takeaway here is this. Start looking at your own systems, your own projects, and really think about how your data is moving through them. And then ask yourself this one simple question. Is your data just sitting still in a lake when it really ought to be flowing in a river?